Okay, so what we're going to do is we're going to go over our warm-up. So again, this is going to y equals mx plus b. My m is my slope. My b is my y-intercept. So again, my y-intercept is -4. My slope is 3, which is over 1. I go up and right. This is going to be a dashed line because it doesn't have a partner. It's going to be greater than, and because it's greater than, I am shading above, right? So again, if you have trouble remembering the greater than, when you extend it, you're 0. Because it's pointing toward the positive, that's greater than. So I'm going to plot these points. I have a -4. And I'm going to count up 1, 2, 3, right 1. And then I said it's a dashed line, so I'm going to connect them with a dashed line. And then all I'm going to do is color above. And then that's it. Now the second one, what I'm going to do is one at a time. My m is going to be -1, which is over 1. So that means I'm going to go down and right. My b is -2. So I'm going to go to -2. I'm going to go down 1, right 1. This is going to be a solid line. And then it's less than, so I'm going to shade below. So what I'm going to do is I'm going to go ahead and connect these two. Okay, and then I'm going to shade below. Now I'm going to do my next one. My m is going to be -5, which is over 1. My b is going to be 2. So then I'm going to go down and right. This is going to be solid. It's greater than, so I'm going to shade above. So I'm at +2. I'm going to go down 5, right 1. I'm going to connect them. And then I'm going to shade above. Now what the actual answer is it's wanting to know where both the colors touch. They touch right here, and that's going to be my solution set. Now back here, this is going to be a solid line. So automatically I can get rid of J and G because these are dashed. This is dashed, right? Then it's also shaded below because it is less than. So this is incorrect because it's shaded above. And so my answer is F. And lastly, this is going to be, it's not a quotient because it's not a fraction. It's going to be a power. A student told me because they know it's usually an exponent on the outside. Another way is the parenthesis is separating them, the exponents. So here's my power. I'm going to have my power. I am going to base it to this. So I'm going to have 3 to the power of 3. And then I am going to take my exponents and I am going to multiply it times the exponent on the outside too. So D, 7 times 3, X, which is also going to be my other exponent, 3 times 3, right? So then 3 times 3. So then here, this is 3 times, which 9 times 3 is 3. I'm sorry, 3 times 3 is 9, times 3 is 27. Then I'm going to solve 7 times 3 is 21. 3 times 3 is 9. Now for the lesson. A radical, okay, it's just this whole thing. So a square root and the number, okay? So let's go ahead and go here. So what it did is it took 15 and it put it underneath the radical sign and 5 underneath. Then from here, it took 15 and it broke it up. It did 3 times 5. When we're going to do this, guys, when we break it up, we want to work with our prime numbers. 2, 3, 5, not 9, excuse me, 7, and so on and so forth. Now, what that means is the reason these make them prime, these are prime numbers, is because the only way to get to 2 is 1 times 2. The only way to get to 3 is 1 times 3. So on and so forth, 1 times 5. For example, 4 won't be a prime number because you can do 1 times 4 or 2 times 2. So that's why 4 won't be a prime number. Okay, so moving on. Okay, then what they did from here is they brought this 5 down. So what I'm going to do is I'm going to ignore these parts right here. So we have a couple, which is the 5s. So they're on a date, okay, and they want to go pay for their meal. Well, when you're on a date, you always have one paycheck because they're usually, with they're respectful, should pay for you or you pay for them, but it's one paycheck. So you're going to take that number, the common number, and you're going to take it out. And then whatever's left underneath, for example, I have 3 left underneath, you're going to leave it there. So when you rewrite it, your 5 is on the outside, the square root of 3 stays there. And then that's it. So we're going to practice breaking it up. So 50. Again, you always start with your prime number. I always like to start if it's even with 2s. You know it's even if it ends in 2, 4, 6, 8, or 0. So 50 ends in 0. And so what I can do is I can go ahead and multiply that times 2. So 2 times something gets me 50. Well, if I'm thinking about quarters, 2 quarters gives me 50 cents, and a quarter is worth 25 cents. So now, can I break it up even more? Well, I can't break 2 up, but I can break up 25. So again, you always try and think prime. So I'm going to rewrite 2. 2 can't go into 25. 3 can't go into 25, but 5 times 5 works. Well, now I'm at my smallest. So I'm going to take my 5, my couple, and I'm going to take it out and bring it here. Then I'm going to rewrite it. 5 square root of 2. And boom. And that's it. Now, let's keep practicing. This one has a 3 on the outside, so I'm going to bring it. I'm going to hold off, and I'm going to do 20. Again, I like to start with 2. 2 times 10 gives me 20. I'm going to keep going. 3 square root. I can't break down 2, but I can break down 10. Again, I'm going to try and start with 2. 2 times 5 gives me 10. And again, I can do 10 because it ends in, I can do 2 because 10 ends in 0. So again, my couple, I can't break it down anymore, is 2. I bring that out front, and you multiply the numbers. 2 times 3 is 6. What's left underneath is a square root of 5. And that's it. So again here, if you decide to keep them separate, you can. So for example, you don't have to bring them together like we did on this one. You can leave them separate. So here's a way you can do that. 3 just stays square root of 3, but I can bring down the 12. I can do 2 times 6, right? I can break down the 6 by 2 times 3. Well, whenever you create these trees, actually, let me rewind. Here, I can do 2 times 6. Once you break it up, this number's done. Then, I can break up 6 by 2 times 3. Because you broke it up, that number's done. So what you're going to do is you're going to take all the numbers that don't have any branches, trees, broken up, whatever you want to call them, and you're going to rewrite them. Square root 3, 2, 2, 3. So I brought this 3 down, this 2, this 2, this 3. Then I'm going to do my couples. Here's a couple, bring it out. Here's another couple, I'm going to bring it out. And you're going to multiply them. So that leaves you with 3 times 2, which is 6, and that's your answer. So if I do 12 times 3, that gives me 36. Well, what's the square root of 36? 6 times 6 is 36. So this is where you need to get a little bit more familiar with your square roots. So let's make a little side note. The square root of 49 is 7 because 7 times 7 gets you 49. The square root of 16 is 4 because you multiply 4 by itself to get 16. Same thing if you have the square root of 25. Well, what number can you multiply times itself to give you 25? 5. Because 5 times 5 is 25. Now let's think about it. Last example, square root of 81. What number times itself gets you 81? 9. So if you become familiar with the square roots, this makes it a little bit easier. But again, we're just learning it, okay? Now, multiple ways, because if you notice, I didn't create little trees or branches or whatever you want to call them, the little arrows down. So that's one way. Those are one ways. Another way, B. I'm going to take 24, and I'm not going to use the square root sign at all. I'm just going to break it up. 2 times 12. Again, I can do a 2 because it's even. 2 times 6. I can do this again because it's even. 2 times 3. Again, once these little branches happen, the number goes away. The number went away. The number went away because you have branches underneath. You're going to take all of these numbers and take it underneath the square root sign. So 2, 2, 2, 3. Find your date. Take it out. Your couple, I mean. You have 2 square root. Then you're going to multiply 2 times 3, which is 6. And that's it. Again, you can do this however you want. If you want to multiply 6 times 3 and get 18 and then break it up, you can. Totally up to you. So if you do that, right, you have 2 times 9, and then you have 3 and 3. Once you have the little breakdown, you bring this 2, 3, 3. Your couple, you bring it out 3. So your answer is, 3 square root of 2. Is it always going to be 2? No. If 2 doesn't work, then you go to 3. If 3 doesn't work, then you go to 5. If 5 doesn't work, then you go to 7. But you're going to break it down as much as you possibly can. Okay? So try F. Now, these are going to be the answers for all of these. You are going to practice. These are the final answers. The one I am going to go over with you is because I'm teaching here is 10. You can do 2 times 5. So that goes away, and you're going to put all of these numbers underneath. So you have square root 2, 5, 3. Where here's the thing, you don't have any couples. So then when you multiply all of those together, you get the square root of 30, and that's why that's the final answer. So again, you're going to work these out however you deem fit. These. So let me zoom in one at a time. 15, the only way you can break down 15 is 3 times 5. Well, again, there are no couples, so that's why it stays the square root of 15. 64, however, you can make 8 times 8. So the square root of 64 is 8. That's why it's like that. Here, square root of 81 over the square root of 10. Now let me actually erase this so you can see. So when you have this squared, when you have a squared and a square root, they cancel each other out. So you're just left with 10. And again, the square root of 81 is 9. So that's how you get those. Now, Another example, okay, so let me do C with you because, again, I'm not with you. You're going to do square root of 48 over square root of 25. Again, if you know your square roots, it helps. Square root of 25 is 5. So I'm going to break this up. 2 times 24, right? Again, I'm going to rewrite it. 24, 2 times 12. And I'm going to keep going. I'm going to break up 12, keep my 2's. To get 12, it's 2 times 6. And again, it's over 5. And so I'm just going to rewrite this because I ran out of space over there. And then again, I can break down. So thus far, excuse me, I broke down my 24 by those two numbers, right? Then I broke up my 12 by these two numbers, right? Now I'm going to break up my 6, okay? And I'm going to write everything down. Now I have 2 3's. And then my 6 is 2 times 3. And I am finally done because I am done simplifying. So now I look for my couples. Here's a 2. I'm going to bring it out. Here's another couple. I'm going to bring it out. And you're going to multiply them. So then 2 times 2 is 4. When you take out the couples, it goes away. You're left with 3 over 5. You're like, Miss Huerta, but what happens if you actually can divide? Again, random example. If I have this example, 3 can go into 6 2 times. So that would simplify to 2 square root of 3. Again, that's just another example to throw out there and things like that. So again, you're going to go ahead and work these out. And if you have any questions, let me know.